Hello, everyone. I'm super happy to be here. It's a real pleasure to be able to talk to you today. Um, we're going to talk about innovations in the Ruby ecosystem. My talk is called "Can we still innovate?" Which is actually a question that I asked myself last year. So, as you've heard, I've been working on a bunch of Ruby libraries for quite a while. And it's been kind of rough sometimes. So last year I was like observing what's going on in our community. I've been watching my good friends, great Ruby developers, basically leaving Ruby. So I thought that, well, maybe I should do the same thing, right? But coincidentally, at the same time, a lot of good things happened. So I noticed that actually we can easily see that the community is expanding. We see more and more projects popping up, people supporting us, people contributing, providing feedback, helping with docs, all kinds of stuff. So that was really positive, and it gave me a lot of energy. So at the end of the day, I realized that everything's fine. So you don't have to wait for an hour to get the answer to this question, actually. So yes, we can still innovate. But yeah, a few words about me. I'm a software developer working for a company called Mojotech. We're a software development and design agency from Providence, Rhode Island. I also have this other crazy job, which is called open source. I try to do that in my so-called spare time. So the first project is Ruby Object Mapper, and the second one, a bit younger one, is called DryRB. We established it last year. So I will actually use these projects as examples of some innovative ideas in the Ruby ecosystem. So first, I would like to talk a little bit about what does it mean to innovate, actually. So I actually Googled it. So it says that it's to make changes in something established. So actually, both things are difficult, because making changes to software is difficult by definition. And changing something that's established is even more challenging, because we are used to certain solutions, right? We know how to do some stuff, know how to solve certain problems in some specific ways. We have our tools that we like, and they make us productive, right? And we feel comfortable when we use them. So like challenging something that's established and trying to change it, to improve it eventually, is just really difficult. But to discuss it, I would like to give you some context. And to do that, I would like to talk a little bit about what happened within the last 10 plus years in our community, in our ecosystem. So between 2005 and 2010, I think it was a really interesting period in our community, in the history of our community. And of course, it started with Rails. Rails was an evolution, a revolution. It was a technology that was truly innovative. People started using it because it changed the way they work, right? It changed the way they write software, it changed the way they write web applications and made them much more productive. But there's one thing about Rails that we kind of know, and we take this for granted these days, and it's something that I think is the most important thing about Rails, which is convention over configuration. And this is something that we just take for granted. And I noticed that a lot of Ruby developers don't even think about it these days. It's just the way things are. We just have convention over configuration. That's how our gems work. And I think it's a much deeper concept, actually, that has had a huge influence on the whole community, on the way we think, on the way we use our software, and also it influenced us and made us expect certain things to just be there in Ruby libraries and frameworks. So there are two aspects of convention over configuration. And the first one is that it just makes us much more productive, because when we start to use a new tool, it just works out of the box. We don't have to spend time on configuring it. We don't have to write a lot of code. But for many years after working like that, it also had a really interesting impact on our mindset, on the way we think about libraries and writing software in general. And there's something that probably many people completely don't think about, is that Rails with convention over configuration raised the bar really high. And it's a really good thing, because it made people focus much more on the ease of use of the libraries. But at the same time, it made us, work much more on various libraries. So it's just harder to come up with something new and show it to the community and have people, be excited about it. Because if it's not super simple to use right away, then people will maybe not reject it, but people will be like skeptical, like, why do I need to add these 2 extra lines of code, for example? And I've seen that many times. So convention over configuration is not just one of the innovations that Rails introduced that allowed us to be more productive, but it's also something that like shaped our mindset. So this is something really, something that we should just keep in mind. This is a thing. It's not just some magical stuff that happens. It's a real thing that needs to be implemented, right? It's a feature of libraries and frameworks that they provide this kind of functionality that everything is just simple. And it's a great thing, but it's really important to just remember about this. This is our, our expectation to have that. So Rails was a huge revolution, great innovations, convention over configuration, and a ton of other stuff, but I'm not going to talk about this because you just know it. But 2006 was an interesting year. Rails was already really popular, right? So we had this article, Skinny Controller Fat Model, and it was the moment where more Ruby on Rails web apps were created, and they started to evolve, and people started having issues. So people started thinking, okay, what do we do with complexity, right? So in 2006, we had this blog post by James Buck who said, skinny controller, fat model. Let's take the complexity in controllers, like move it to the model, because model is the appropriate place to put complicated code. So at that point, I think something really interesting started to happen, because we started to have this discussion about how do we deal with growing complexity. Because we already knew what do we do to be super productive. We use Rails, right? So it's a framework that makes us super productive. But applications started to grow, and our code became more complex. So what do we do about that? So the discussion started roughly around 2006. So we identified our enemy, complexity, right? Like, this is something that we need to struggle with. And it's going to get worse if we don't do something about that. And this was this interesting, like a background discussion that was just happening behind the scenes, sort of. People were writing blog posts. People were talking about the ways that they deal with complexity on conferences. But our ecosystem was evolving at the same time, right? So years were passing, and it was like 2007, 8, 9, and we've been trying to solve the problem, which is complexity. And one thing that we realized is that fat model was just an ambiguous idea. Like, nobody actually knew what it means exactly. So people typically realized that model is active record, so they started using this, and it didn't work very well. So more people started exploring various approaches. A lot of experimentation started in the early days, like 2007, 2008. So we started seeing people talking about, for example, domain-driven development, right? Maybe that's the way to go. It's a known set of patterns and practices, so maybe we should just adopt it in our code so that it will help us deal with complexity. Some people started looking into DCI, right? Data context interaction, I believe. So a lot of experimentation. And there was this thing, SPFDL. Have you tried that? It's really good. I mean, I made it up, but it actually means something. It means separating persistence from domain logic. And it was another really big topic that we started discussing, I think back in 2009, 2010. So people identified that, okay, we have issue with the active record pattern, so maybe we should do something about that. So the obvious conclusion was, okay, let's separate things. Let's have something that deals with persistence and something that is part of our domain. So we're going to split things up and then end up with proper separation of concerns. So that sounds great, like theoretically, right? But how do we do that exactly? Like, what kind of libraries do we need, or frameworks? What kind of patterns should we follow? So it wasn't a simple discussion. There were many things that we could do, like maybe we should use repository pattern, or maybe we should use a data mapper pattern. So this discussion just kept going. What do we do with complexity? And maybe we should just change our strategy to for dealing with persistence. So this was happening sort of in the background, but Rails was still evolving. So at the same time, I think in 2007, many new libraries started to show up. So we have new libraries and new frameworks. Specifically, I would like to talk about MERP. So MERP was introduced in 2007, but it was a hack, actually. It was a hack to make file uploads faster and thread safe, if I remember correctly. So this is a MERP website. It's actually from Internet Archives, because it's no longer online. So from my point of view, MERP was the next, I should say, huge innovation in our community after Rails, because MERP did two things. The first one was it actually proved that we can have a fast Ruby framework. Rails back then was really criticized for being slow, and MERP fixed that. It proved that, okay, it's Ruby, it's not a super fast language, but we can have a faster framework. So they did that. Furthermore, they changed the approach to how we create a full-stack framework. Full-stack framework is something extremely complex. There are so many things involved in this stack. So they changed the approach. We're going to have something that's modular, so that you can cherry pick what you need. I'm not sure if you notice this catchy phrase, all you need, nil you don't, right? So you could have a MERP stack that is very lightweight, that is not a full stack framework, it's just a couple of pieces that you need. And this allowed us to have something that's just faster. And there was one more thing that MERP introduced, which I found to be innovative back then, and it was something called ORM agnosticism, if you can say that even. It allowed us to use different ORMs, not just Active Record. And actually, coincidentally, we had new ORMs. So SQL was created in 2007. A few months later, Data Member was created, also in 2007, so many years ago. So MERP not only showed us that we can have a faster framework and more modularity, but it also showed us that we can use different ORMs, and different ORMs started to grow. So that was another really interesting and important, I think, innovation, that we had new ORMs. And they also raised the bar when it comes to ORMs, because they had features that Active Record didn't have back then, like lazy queries, dirty tracking, custom data types with coercions. All this stuff was pretty innovative back then. So if you know the story, you know that this happened in 2010. So essentially in 2008, both Rails and MERP teams decided to just work together, because their goal was the same, to create a really good web framework that is a full stack framework that follows convention over configuration, that has all the stuff that you need in order to build a web application. So Rails 3 was released in 2010 after, I think, a year and a half of work. And it was a huge release. Rails became much better. It adopted all kinds of ideas from MERP. So it became more modular, it became faster. You could use different ORMs with Rails. You could use different testing frameworks with Rails. You had better generator API. A lot of smaller innovations were part of this release as well. So that was another huge milestone, another big innovation in our ecosystem. And that was in 2010. But remember that we still had this kind of background discussion about, okay, but how do we deal with huge Rails apps? We still didn't have any answer to this question, like, how do we deal with complexity? So this discussion continued. And in 2010, when Rails 3 was released, a lot of people had huge expectations from this release. A lot of people thought that it's going to change everything. It's going to become, it's going to introduce more abstractions. It's going to change Active Record to something else. But that didn't happen, so many people were kind of disappointed. So years were passing. We just kept discussing what do we do with complexity, like all the time, all these years, and we were just discussing and trying how we can solve this problem. And that was an interesting moment. In 2012, notice that it's October 17th, 2012. It's like literally 6 years after Skinny Controller Fat Model blog post. So it says 7 patterns through refactor fat active record models. 6 years, right? So 6 years Before that blog post, we had an idea, let's move complexity from here to here, and if it's here, it's gonna be better. But it took us 6 years to figure out that, nope, I mean, it's still gonna be there, right? So this was a really, really important blog post, I think, and I think it's still quite popular. So it introduced a couple of new abstractions, because at that point, we had already enough experience to actually identify what kind of abstractions we actually need, and we could actually name them. So it, for example, talked about form objects, value objects, service objects, all kinds of new abstractions that people could use to make their applications simpler so that it's easier to maintain them. At that point, we also had many people working on actual gems that would either provide these abstractions so that you can just use them, or provide some lower-level tools so that you can build these abstractions yourself with less code. At the same time, we still wanted to have this, like separating persistence from domain logic. This was still a subject to discuss, because we still didn't figure out how to do that exactly. In 2012, we had a couple of implementations of Data Mapper, but they were pretty young, not really, production ready. So there was this huge effort that was called Data Mapper 2. So I was involved with Data Mapper. I was part of the core team. And in 2009, we decided that we're not going to continue building a better active record, because Data Mapper was actually an active record pattern library. We decided to move to a different pattern, and we obviously wanted to use Data Mapper because the project was called like that. So it made a lot of sense. But we actually really believed that creating this amazing ORM, implementing this powerful pattern, will just solve our problems. And it didn't work. We actually didn't implement it eventually. But there are two things that came from this project. So the first thing was Virtus. And Virtus was introduced in 2011, so that was 5 years ago. And it was literally almost copy and paste from Data Mapper to a new project, changing names and adding a couple of new features that I missed. And I just released a new gem. So Virtus, it's still the same. It's an API for defining attributes with some optional coercions and additional features. But I remember specifically that 5 years ago, when I introduced this library, people were asking me questions like, why do I need an object with attributes that I cannot save in the database? And I really didn't know what to say. I tried to find some good arguments like, because it's simpler, because, I don't know, because it's going to be easier to test. I couldn't like properly describe it, like, what's the point? But it turned out to be useful. People started using it for stuff like form objects, or using it to map JSON to more richer objects so that they are simpler to use. But that was 5 years ago, right? So we spent 5 years trying to figure out that as a community that this kind of an API, I'm not specifically talking about Virtus now, this general concept of an object that is not connected to a database that just holds data and that's it. It took us 5 years to actually realize that it's super useful, that it's actually pretty nice to work with simpler objects. And I actually noticed a few months ago that Virtus' popularity is still growing, and it started to grow faster last year. So 5 years from it makes no sense to everybody is using it. Furthermore, there are like, I don't know, 8 or 9 gems that were inspired by Virtus, so people just implemented the same thing but addressed some problems that Virtus didn't solve, like performance, for example. So again, a very long process, right? Just like with skinny controllers, threat models, 6 years to figure out that, well, nope. And here it's exactly the same, like, why do we need that? 5 years, of course we need that, right? So we are constantly evolving, we are still learning, and even though in the beginning we may be a little bit skeptical, maybe a little bit confused, but it takes time to actually, evaluate something, experiment a little bit, and realize that, oh wow, this is actually useful. So the next thing that came out from Data Mapper 2 effort is RubyRB, and this is a much bigger project than Virtus. So RubyRB has a longish history. It started in 2013, but its first release that was actually useful was in 2014, exactly 2 years ago, in November 2014. So Ruby Object Mapper became something that is pretty unique in the Ruby ecosystem because it's a library that allows you to work with databases and in data in general, but in a less object-oriented way, right? So again, we have this confusion like, why do I need that? It's an object-oriented language. Give me object-oriented API. But nevertheless, ROM uses objects because it's written in Ruby, right? And we have a lot of object-oriented APIs. It's just that it's no longer a typical object relational mapper. So at that point, we have 2016, and now we're going to get more technical. So I will show you ROM-RB as one of the examples of something that at least I find to be interesting and innovating. And then I'm going to show you dry-RB and a couple of examples from dry-RB. So if you're not familiar with ROM, it's a open source persistence and mapping toolkit for Ruby built for speed and simplicity, right? I know these are like buzzwords, but it's really built for speed and simplicity, so I really don't know how to describe it better. So one thing that changed drastically in 2014 was that I rejected a lot of common stuff from ORMs, like, for example, dealing with mutable objects. It's just gone. Like, we don't use that anymore. We don't want to have that. And it actually completely removed a whole big chunk of code that was already very complex, very slow, and even not finished. So we just don't want to use mutable objects. And it also resulted in a library that is much simpler, that focuses on data and data processing. So eventually we actually do have something that is faster and simpler, right? So these are not just buzzwords, trust me, please. Right, so a couple of innovations that I think are quite unique in Ruby. We decided to separate reading from writing. And it's, I guess, a natural outcome of this decision that we're not going to use objects to make changes in the database, that we're going to just use data. So what it means is that we have data that we return to, I don't know, a client, or we display it in some user interface. And then we have different data that we use to make changes in our database, which is exactly what happens, right? We have a web form, and it has some structure, and when you submit it, you get some data on the server. And it's almost never the same as the data that you use to display, for example, in the user interface, or to return as a JSON. These are just two different things. And you may think that when you separate stuff, you have two things to worry about, so it's going to be more complicated. And it's actually the opposite. When you separate these two things, you actually end up with way less concerns. Furthermore, it's much, much easier to optimize all the queries for reading and to get something that is much faster to make changes in your database. So the second thing that is quite unique, I think, and innovative in ROM is that it has this idea of relations as the first-class citizen in the application. So when you compare that with Active Record, where you also have relations, which is like specialized objects for like creating complex queries and talking to the database, but they never were first class. It's an API that's there. There are some people who wrote some gems to make it easier to use ARL, but it's not a first-class concept. The first-class concepts are Active Record objects, and they're classes that expose some query DSL. So in ROM, relations are first class. They are the objects that provide data to your application, and you have complete control over how it's done. The next thing that is quite innovative is moving away from mutable objects. And I know that it's super confusing for some people because we are so used to mutability in Ruby. Not using mutable objects is so much simpler. It only feels harder in the beginning, but trust me, when you want to make changes in the database, you receive data, you validate it, maybe you convert it to some different representation, maybe you curse it, and then you store it. But with objects, you receive data, you create an object, then it changes, then it gets sent to some lower level part of the library, and then the data is extracted again from this object to send it to the driver that stores it in the database. So why do we even need that object in the between, right? Like, this makes no sense. It's just an overhead. It's just an additional complexity, right? So we decided to take a different approach and just focus on the data. We have data, we just want to save it. That's it. We may convert it, we may validate it, we should validate it, and that's it. So like a whole layer is gone. No mutable objects. Another thing that's kind of innovative is the common API, because we have objects that are dedicated to make changes in the database, and they are like optimized for specific databases. So for example, we have Postgres-specific commands, so that we can do stuff like multi-insert, or we have upserts, native support for upserts. This is pretty cool. It makes it easier to do like more advanced stuff, like I know, importing data, for example. And another thing that's kind of unique is lack of validation in ROM itself. Like we just don't have this idea that we have validation. So we can validate data however you want outside of ROM RB. So this is a bunch of stuff, as you can see. I'm going to show you a couple of examples just to give you an idea how it looks like. So first of all, I'm going to show you an SQL example, but I should mention that ROM is actually built for any database, any data source. You don't have to use SQL. We have adapters for other backends, although SQL is the only really mature. But we have stuff like YAML adapters or Git adapters, and they are actually no jokes. They are used in production in real-world use cases. ROM SQL uses SQL, their library, as the backend, so you might be familiar with the syntax. So this is just a migration that creates some tables with some columns, and it sets up some foreign keys. So this is pretty common. We have all kinds of APIs for like setting up your database, configuring various special features, like in Postgres, like PGJSON, all this stuff. It's all there. So it's pretty common. And then you have relations, and this is when it gets interesting. So relations are objects that provide data. You define a class, and then you get an object, and it just gives you data. And now I want to go back to the convention over configuration that I mentioned in the beginning, because you need to notice how it influenced ROM design. There's a lot of stuff going on behind the scenes. Like, you cannot just have a relation class and connect it to a database, right? You need a lot of information, like, okay, how do we, what's the name of the table, obviously? What are the attributes that are returned by this relation by default? If I told people to define this manually, like, people would hate me, right? Nobody wants to do that. So we need to follow convention over configuration, and it's a great thing. I repeat, it's a great thing, but it adds additional effort to the process of building a library, right? So here we have a schema. Every relation has a schema, and we say that we want to infer that, which means that we're going to look at the database, look at the structure, and just infer information for our schema. But there are some small differences, like we need to write schema infer true, right? So we're like more explicit, so that when somebody is looking at the relation class definition, we know that it has a schema, right? It's not super magical behind the scenes. We know that there is a concept of a schema. The name of the class has an additional meaning. We can infer table name from it. This is a very common thing, like in Active Record. So again, we have a library that was built like 2 years ago, and it still follows the same patterns that were, the same principles that were established like years ago. We still have that, right? And it influences the way we build libraries still in 2016 even, right? So another thing that's interesting about ROM is that we avoid global state. It's funny that I asked Luca about what he could have done differently in Hanami, and he said, well, avoid global state. So awesome that you said that, because it's really in line with what I'm about to say. So ROM doesn't have global state, or I should say it tries to avoid global state as much as possible. Like, relation classes are global per definition, because classes in Ruby are globals, and they are mutable global variables. But what you use in ROM at runtime, these are just objects. There are no global states, so connection is stored in an object. There's a registry with relations, there's a registry with additional commands or mappers, and these are all objects. So you can have something that is very well, like self-contained, very isolated from the rest of the universe. So when you configure ROM, you just ask it to give you a container, and the container is this small isolated object which gives you access to all components that ROM provides. Now, this is something that obviously happens behind the scenes when you're using ROM with some frameworks, because frameworks should do that for you. But I think it's important to notice that this is just a different philosophy when it comes to building a library, when you just don't want to pollute global namespace. And it's also an extra effort. You don't get this for free. Like it's a pretty significant effort to build a library that is focused purely on objects and doesn't have anything that will like change accidentally some class in some distant place, right? So we don't have this kind of side effects. We want to have objects exclusively. So ROM has this idea of repositories, and this was created specifically because people want objects at the end of the day, right? We don't want to work with hashes all the time, although there are use cases like when you're building a JSON backend, a JSON API, we actually have a case where somebody asked us for a feature that would only return hashes, that would not create any kind of objects, any kind of structs, because they just want hashes. So there are really good use cases for very simple mapping between your database and your Ruby objects, where Ruby objects are just hashes and arrays and strings and numbers and all these primitive types of objects. Nevertheless, repositories are pretty useful because they allow you to map simpler objects like hashes to more advanced objects, like your custom structs, for example. Furthermore, repositories make it easier to make changes in your database. So they are like a front end for the lower level commands. So here's an example. You can define a repository to work with a very specific relation. So in this case, it's a users relation. And then we can say that we're going to create new users. So we say commands create, and your repository will be set up to be able to create new users. And again, we don't have a global interface. You need to create an instance of a repository, right? So there's no global user repo.create, for example. You need to create an object. And then you don't create an object to save it. You just pass in data, which is a huge difference between what's common with objects that save themselves, like with Active Record, right? Or even in Data Mapper, you would still use objects that get changed and somehow converted to something that can be stored in the database. So we don't have that. We just pass in data, and the data is persisted in the database. Now notice that there is a difference in the result here because we don't get hashes back. We get the automatically generated struct objects. Now this is just for convenience, right? This happens behind the scenes. And again, this is one of those things that is just nice, right? You get a lot of functionality for free. It wasn't super simple to implement it, but it's just worth to have that, because people can easily work with very simple struct objects without the need to create their own classes. Another thing that you might be familiar with, actually, if you've ever used Ecto from Elixir, change sets are very similar in ROM. They're not as powerful as in Ecto, but we're getting there. So change sets are objects that allow us to make changes in our database whenever something more advanced needs to happen, although using change sets in general is just a good idea because they encapsulate this process of I have data that might be different from what I have in my database. So there are some additional features that are just useful. That's why this separate abstraction is just a pretty nice thing to have. So repository can be configured to update data, not just create data. So we can say like, okay, we're going to update data by primary key. So by p key is just a built-in relation view that restricts its data to a specific primary key or primary keys. So the way you can use it is just to create some data and then ask repository for a chain set for this specific primary key. Then we can like look at the diff, like did anything change? Does it make sense to actually go to the database to store it? So this happens behind the scenes. Like if we pass change set to the update method and the diff is empty, then we're not going to go to the database to change it. Now there are other features that are just not completely finished, so I'm not going to show them to you because of that. But change sets are a really powerful concept, and we're going to like keep evolving this API. I'm pretty sure that Actor change sets are a great inspiration here. So This is something that is just different. Like, it's not common to do things like that with Ruby, but it actually makes a lot of sense, and it's actually simpler and faster. So let's talk about aggregates right now. So in Active Record, you have typically associations, right? Like you say, user has many tasks, which means that there is a user object and it's going to have many tasks. Now in ROM, we have a general idea of aggregates, which are just nested objects, potentially deeply nested objects, where there's a root object and children objects, like user with tasks. It seems like the same thing, but it's actually completely different, because it doesn't have to match what you have in your database. So separating persistence from domain logic, this is exactly that. You can define your own objects with your own structures, but you don't have to have it match the database structure. However, this is what typically happens in the beginning of every project. Every project starts simple, right? So we create tables in our database with some columns, and suddenly we have associations. So we have users with tasks. It can be modeled in the database, and it matches perfectly what we want to have in our application. So this is a very common use case. That's why we want to support it. That's why we want to have it as simple as possible. So we added support for associations DSL, just like with Active Record, right? So we can say associations has many tasks, and there you go. Now we can do stuff like this. You can ask repository to also work with additional relation called tasks, and we can persist deeply nested data structure where we have users and tasks, and we can like store them in one go. And this is just the common case, right? Like we can cover a lot of common cases and just make it as simple as with Active Record, even though they don't have to match. Like you can diverge from your database schema. So we can ask repository to load all users with all their tasks, and you're going to get back an array with user objects and task objects embedded inside them, right? So we will get this aggregate back just automatically without the need to write any queries. But it really boils down to this, custom objects. This is like the main goal. Eventually, we want to have the ability to like define our domain the way we want, the way our application wants, so that it's easier to work with the data structures that the application relies on. The stuff that we have in our database is optimized for the database. It's never optimized for our application, especially if the app is really big. So we can create custom objects. Let's say we're going to use dry struct here, and we're going to just define some classes with some attributes. It's a very similar API to Virtuous, as you see. And then we can just ask repository, hey, give me the same aggregate, but as a user objects, not as the default built-in structs. And that's pretty much it. Like, you can have custom objects mapped automatically, and they don't have to match the database. You can, at any point in time, define your custom logic for fetching data, but you can still keep this structure here. It doesn't have to change. Like you can, split tasks into multiple tables and just write a query that fetches data from multiple tables and just get it back as task, right? So, yeah, this was an example of dry struct, so it's a good moment to talk about dry-RB. So dry-RB is a big already, but a new project that was established last year. We created dry-RB with my friend Andy last year, and it just exploded, literally. Like in a few months, we went from few gems to 10 gems, and then just suddenly we have 22 or 23, I don't remember exactly. So this was a really amazing experience for me. As I mentioned in the beginning, I felt like maybe this doesn't make sense, and then dry-RB started to grow so fast, so that was pretty good. So dry-RB is a collection of next-generation Ruby libraries, each intended to encapsulate a common task. This is from our website, and it is just that. It's a collection of small libraries, and we try to solve common problems, but use some more modern approaches to programming in Ruby language. So just to list a few things, we have stuff like advanced data validation. We have a type system with coercions and constraints that is sort of like Virtuous but more powerful. We have composable transactions that you can have that you can use with really cool error handling using monads. And monads are kind of from a foreign land called functional programming, but we actually use it and it actually works. We have controversial subject dependency injection, which is the reason why many people just reject dry RB altogether. But it's not a great idea because it's just two gems that use dependency injection. Everything else doesn't have to use it. We have a low-level gem that manages application state and provides something that is called component lifecycles. And I will actually show you a couple of examples. So I will show you dry struct, I will show you dry validation, and I will show you dry system. So you've seen already an example of a dry struct. So this is a similar API to Virtus. It provides a way to define attributes in a class with names and types. Now, the big difference here is that you don't have attribute writers. You only have attribute readers, which confuses people, but that's on purpose. Like, these objects are meant to work as plain data structures. There should be no reason to change them. Another big difference is that types define the whole behavior for processing individual values. So this type strict string here, for example, is a type that will make sure that this is always a string and nothing else, and it will erase an error. So here's an example. Dry struct uses a gem called dry types, which is like the underlying engine for custom types and coercions and constraints. So we can define, for example, age type, which says I'm a strict string, integer, and I must be greater than 18, right? And it's a well-encapsulated small object that you can just use in different places. So here we use it for the user struct, and we say dry types, types age. This is the type of age. And the result is that when we try to instantiate this user with a age value that is not greater than 18, then it's going to raise an error. Now, this is something that I've been trying to explain multiple times in multiple places. That creating objects with broken state makes no sense. Like, if you can have an object that plays important role in your system, and it's possible to have that object broken, I just cannot understand it these days. Like, why do we do that? So this is pretty useful, actually. This is used in production, and one of the things that I really like about this approach is that when I have some more complicated database queries and I create objects from the data returned by these queries and I screwed up something, then I will actually see an error. And it actually helped me a few times. So that's pretty useful. It's not a joke, it's a real feature. So this looks sort of like data validation, but it's really not about data validation here. Like, dry structs are meant to be simple objects that should be valid always, that should provide data, just data structures, right? But we have a solution for data validation, which is also something that is quite unique. It's called dry validation, and it's a different validation library. Specifically, it's a validation library for validating data, not for validating objects. So the common thing in Ruby is that you have an object with some state, with some data inside, and you ask it if it's valid, right? So dry validation moved away from this idea because, first of all, we don't want to have objects that are invalid, and secondly, we don't want to create an intermediate object just to validate it. We just want to validate data. So this is another example of a more data-centric approach where we just don't create objects that we don't need. So dry validation creates validation schemas, and it uses schemas to validate data. So here's a simple example. We have a schema that defines two keys. Now, there is another difference between validating data and validating objects, which is that in case of data, we can actually validate the structure, not just the values, but also the structure. So we can actually check, for example, if we have login and age keys. If they don't exist there, you're going to get an error that the keys are missing, right? You're not going to get an error that the values cannot be blank or nil or something. You're going to get an error keys are missing, which is the correct thing to do because that's what happened. So apart from validating keys, we can obviously validate values. So we have this DSL for defining various rules for values. So this one says that it must be a string and it must be between, its size must be between 2 and 64. And here's we have something more fancy. It's called maybe macro, which says this could be nil. And if it's a nil, then we're done. If it's not nil, then please check if it's an integer and if it's greater than 18. So this is a very simple example. You get back a schema object, and you can call it. If you're confused by this, this is just a short version of explicit call. And as you can see, we just pass in data. So we get back a result, and the common thing to do is to obviously see if there are errors. This is baked into the library. We just created something that is very common, which is the ability to define error messages for individual rules. You can like translate them into different languages. So that's like built into the library. But it doesn't have to be this, actually. So the errors are represented using a data structure that you can convert to anything. We just happen to convert it by default to string messages inside a nested hash, right? So another interesting thing is that schemas are composable. This is pretty useful. The library is called dry validation, so we don't want to repeat ourselves. So we have, for example, an address schema, and then we have a user schema. So we can say that, okay, there's a required key called address, and the schema should be validated using the already existing schema called address schema. So this allows us to reduce a lot of duplication, and it's especially useful if you've got a ton of really big schemas where you can just, encapsulate certain parts of the schema inside separated schemas and just reuse them. And last but not least, validation hints. This is, I think, still super experimental, but it's one of these examples of something that is just new, and we just need to like evaluate it and see if it's actually useful. So the idea behind validation hints is that there are errors, like I showed you in the previous example, like this one. We have age, it must be an integer. We pass a string, we get an error message back, must be an integer. But you remember that we actually also want this to be greater than 18, so there's more information related to this rule, to this field. But this is not what failed, because what failed is that we got a string and it must be an integer. We cannot even check if it's greater than 18 because whoops is not greater than anything, right? It's just a string. And actually, dry validation can provide you this information as hints. When you define rules, we can take those rules and translate them automatically to a set of messages that you can provide to the client in the UI, whatever. So if you call a schema, you can ask it for hints. And hints, in this case, this is the default hint, which looks like an error, but you can like override it to be something else, like, hey, and remember that this must be greater than 18. If you're not, old enough, don't bother submitting this form or whatever. There could be use cases for it, so I encourage you to just check it out and experiment a little bit. But this is one of the examples of what you can discover if you just try to approach something with a fresh mind, like let's experiment, let's see what we can do. Because hints are actually an accident. Like I wanted to provide error messages, and because rules are executed using predicate logic, so we don't execute all the rules, we don't always get all error messages, but we want to get more information in some cases. So I created hints, and it turned out that it might be a good idea to actually have them as a separate feature. So they were promoted to something that is called hints right now. So yeah, that was dry validation. There is another thing that I would like to show you, although this is something that many people will probably not care about. But I want to show you just as an example of how certain problems can be approached differently when it comes to managing application state, handling third-party code, or handling your own code even, by using, and now horrible word, dependency injection. So dry system was created as a simple experiment just to see if I can load code, either my own code or third-party code, and encapsulate every component that I have in my system in complete isolation. So that, for example, I could have a rake task which requires just 2 pieces of my application, and I want to load only these 2 pieces. And only the code that is required for these 2 pieces should be, well, required, right? So I don't want to require all the gems and everything that I have in my system. I want to be able to cherry pick. So things should be somehow organized and somehow separated and somehow handled properly. So Dry System provides you a way of managing this for you, but you need to use a container, right? It's an explicit way of dealing with dependencies, with object dependencies. Don't confuse this with bundler. It's a different topic. So when you use Dry System, you can create, for example, an application class that inherits from Dry System container, and you configure the root path, and then it becomes a simple registry of objects, right? So you can like register logger and say, yeah, I have this logger here. I'm going to create an instance, store it under utils.logger, and then it's going to be available. So this looks weird probably, but yep. There's auto-registration, which is a way of reducing boilerplate code. So in Ruby, we have a lot of common patterns for defining classes and instantiating them. So one of the patterns that is quite common is to have a constructor that accepts some dependencies, and that it assigns these dependencies to some instance variables, and then they are just available, right? So there's a lot of boilerplate. When you write it all over again, it's just super boring. We don't want to do that. So we added support for auto-registration, which means that you can use a special directory structure and file naming convention so that Dry System will automatically register all the components that you have, all the classes, and they will be available automatically. So this is as simple as setting up auto-register to some directory. It could be a single directory or multiple directories. So then if you put, for example, liblogger.rb with a class logger, then at runtime, your application container will just have logger automatically available. So this reduces a lot of boilerplate code, because if you build the entire app using dependency injection and using container, then you're going to have a ton of classes with boilerplate. So you don't want to have that. So we reduce that significantly by introducing auto registration. And sort of related to that, we have the concept of booting components. And this is actually the reason why I started working on this library, because I had a lot of issues with loading code in an efficient way so that things get loaded in correct order and they are not loaded when they are not needed. So like specifically rake tasks or tests, especially tests. So booting components means that we can have multiple like lifecycle hooks for individual parts of your system. When something is really complex, like it needs, for example, third-party code, then we need to do stuff like require this code and maybe configure something and maybe create some object and store it somewhere, right? So Dry System provides you an API for defining a component, giving it a name. Here it's called persistence. And let's say we have some third-party database object. And we can say that when we initialize this thing, we just require this code so that it's available. We don't always want to really initialize it and connect to the database and create the object, but we may want to have the class available, for example. It actually happens in places like tests, for example. Then you can say, when we start this thing, we're going to register database object under database key. So eventually, it's going to be available for us automatically in places where it's needed. And then we can also say that, well, we may need to stop it, which means disconnecting from the database, as an example. So eventually, you get an API that allows you to ask your own application container to boot entirely the persistence component, which will require needed files, which will perform all kinds of setup if it's needed, and as a result, you're going to get back your application that has access to this concept of database component. Now, how it works in practice, we typically use something called auto-inject, which means that we only require one module from the setup that is provided by Dry System, and we say that this class, in this case some worker, whatever, it doesn't matter, it needs a database, right? So we want to have a database available inside this object. And the only thing that we need to do is to say, hey, import database. This can be called import. This can be called differently. You actually define it yourself. So it's up to you how you name it. So this is heavily based on dependency injection, as you see, because we use object identifiers. We don't create classes manually in our classes, and things just appear in your code automatically. So, right, I forgot about this one. So this is a different way of organizing code, and it's I guess something controversial, because every time dependency injection shows up in some article or some Reddit thread or whatever, people just love to hate it for some reason. I believe it's just like the result of Java hate, that eventually it just survived for so many years that whenever we hear about a container or a constructor injection, like people think about Java days or .NET days, and they just don't want to go back to this. But it's really different in Ruby. It's much simpler in Ruby. And to be honest, I built a couple of applications with this style of code organization, and it feels really, really good. Like, you can define all kinds of components. They are isolated. They don't strictly depend on each other. Sorry, they are not coupled with each other in terms of like constant names and all the logic that is required to create individual objects. You just have them available, and you use abstract identifiers instead of concrete constants, so that you can replace things easily. And another great benefit is that your entire application API is available through these identifiers. Like, you can have, I don't know, some operations like create user or delete task or whatever. And you never care about object instantiation. You just ask your container for a specific part of your system that does something that you need in some place, and it will be just there for you. So yeah. 4 minutes left. Right. That was a bunch of code examples. If you have any questions, we still have time for questions. I just wanted to like finish this saying that really in 2016, I think many great things are happening. I showed you projects that I work on, so it's not like I consider only this to be somewhat innovative or new or fresh or whatever. There are lots of interesting projects that are still growing, and probably many more projects will show up in the future. So it's not like I showed you the only thing that is happening. So there are lots of great stuff, lots of great gems in Ruby, like Hanami, for example, or Trailblazer, a ton of smaller gems. Like recently I saw a gem that implements date and time calculations without any monkey patches, with a really, really cool interface. So a lot of people are still exploring and still experimenting. So I would just like to continue doing that. I thought that Ruby is kind of becoming like stale and nothing is happening, but we are doing this all the time. We've been doing this since like 2004 or 5, ever since Rails was created, and we like became, you know, a huge community. So there's a lot that can be done in Ruby. It's just a matter of like staying, you know, with an open mind and approaching things with like curiosity. Even if something looks weird, maybe there's a reason for it looking weird in the beginning. Maybe, you know, there is some value in it, even though it looks weird, but maybe you should try it, and maybe you will find that it's pretty cool. So yeah, that's all I got for you today. If you have any questions, we have now 3 minutes. But yeah, I'm here until Sunday, so I love to talk about Ruby. I love to talk about programming, abstractions and everything, testing. So yeah, talk to me. We have still 2 days. Thank you. Yeah. Yeah, so the question was about innovations in the Ruby itself, in the Ruby language, right? Yeah, I had like 3 versions of this talk, and in one of the versions, I actually had some examples of what could be done in Ruby, but that's just such a deep topic that I decided not to do it. But yeah, since you asked, yeah, I think there are lots of things that could be done in the Ruby language itself. For instance, finally we could do something with method objects versus lambdas versus procs, somehow unify this. we could finally do something with the issue that was reported, I think 4 or 5 years ago, about how about introducing proc composition operator, but somehow they cannot figure out how it should be named. So, I would love to see some features related to object immutability, like having some way of creating objects that just by design cannot be changed, and without the any kind of performance issues. Because if you really try to make something immutable in Ruby, you're gonna have to deeply freeze it, and sometimes it's just super slow. Or I should say, it's always super slow, and sometimes it's so slow that you cannot accept this. And I would love to see this kind of features in Ruby so that I can, have objects that don't change without the performance penalty. So that would be another thing. So I think that something for creating objects that work like functions would be nice. In general, like a first-class function concept, but not as a proc, but as a function, like in Scala, for example. That would be another thing. I could probably come up with more, but not at the moment,